How's it going, everyone? Eulier Gonzalez again. Looking at the React Performance course, which is a course taught by Steve Kinney, head front-end engineer at Temporal, this open source tool that is now a durable execution platform that helps to cover specific business use case. So for example, Vercel actually paid for that product. So the idea of today's video is to now dive deep into the escape hatch, so be able to describe that and understanding is the life cycle of the React effect, which is something that I'm quite familiar with, separating events from effects and be able to describe that. And not only that, but when it comes to actually need to add some logic to this, we can safely do that. And then you have is the removing effect dependencies. And last but not least is reusing logic with custom hooks. The idea of this is that connect all of the dots, being able to describe all of this concept in English, by the way, and then we can move on finally to what we really care about with this particular course. And one of the techniques and tools that we're going to look at this as a way to now not only be able to write React components in the most performant way, but also React applications. So on that topic, okay, let's get into this. So this course is structured in this way. You got the introduction, React rendering, reducing rendering, context and suspense. But if you want to know how to improve something, you need to know how that thing works. What is the mechanism behind the scenes? So with that, once we're able is to describe and actually understand, at least in the performance and in the context of computers, React application, and also you can apply that to your life. So performance in the context of React is it is much faster to not doing stuff than doing it. And there's some corollaries to that you can apply also to your life. It is much more faster doing things right now, or it's much more faster doing things later than doing it right now. So this is also to talk about is the prioritization, task prioritization, attention prioritization, and how important and helpful it is to do that as a way to now focus on what really matters, slow down the pace, look at the context, see where you can get and what are the connecting dots that you are making, this new neuron connection that you're doing. And then is when you're going to elaborate, going to move on toward that as a way to also build this, in our particular case, well, the React components in the most performant way. So this is the reason why we are looking now at the React docs, which is, well, thanks for all of the people in the community that actually make this possible to create this storytelling as a way to make sense of how do we get here with React, okay? And this is a process that takes time, and the more commitment you do to this, the better off will be for yourself and for others, for your team, the PMs, the designers, as well as the shareholders. So this is the reason why we are looking at the escape hatches. I'm going to briefly recap all of these topics as a way to now understand how do we get here. So React, after all, is a JavaScript framework which allows to describe UI. We look at how, which is user interface. We look at how can we now import components export components, using the GSX as a way to now allow us to write HTML that can connect with JavaScript world using the GSX or these curly braces. And how can we now pass data to these components as props? How can we conditionally rendering our components, rendering lists of components, and also how now it's important from you when it comes to write your components to make it pure, because there's some benefit for that. So now this component can run in any JavaScript environments, catching, and it is safely to stop the rendering execution. Rendering execution, which is now the process of what's going on when you're starting to describing your UI, when you want to update your state, is part of the React Now way of how now React architecture or organized is this way of doing, of way of describing UI, which is you have the render tree, you have the tree of dependency. So the first allow you to identify, the first allow you to see how the data flow go through that, through one-way data flow, and the text on performance issue, and the tree dependency allow you to add some functionality that you want to make this component, or that you need for these components to become interactive, because otherwise we're just writing these single HTML elements. So as a way to provide now this interactivity, we use the event handlers by passing these functions to those event handlers in our GSX. And when it comes to now show data to the user and update that data, we do that using a state, which is behind the scene is now using is a closure. So all of the things, and the use case or the reason of using a state is, for example, when you are in your bank account app and you want to send money to your mom, you want to know is your current balance account, perhaps your transaction history, your profile data, okay? And when that transaction is settled, now you want to see your balance updated. So this updating process, okay, as a way to now show this interactivity to you as a user, is now being done by this state. So anytime you update the state, React will pass through the rendering mechanism, which is the trigger, rendering, and commit. So what does it mean? That is, anytime you trigger and state update from the event handlers, so you're gonna pass through the trigger, rendering, and commit phase. The trigger is when this will happen. It was caused at the root element, or as a component, or any of its ancestor that cause the state updates. So in the render phase is when now it's say, if it was caused at the root element, then I'm going to now create all of these elements for that. If this was caused by a re-rendering, I'm gonna call the component that triggered that state update, going to compute that function with its props, the states, and also the reactive values, which is whatever you define inside of the body, okay? And exactly. And now the output of that, if that contains more React components, I will now recursively calling until there is no more components. While doing that, I'm going to recreate the virtual DOM, which means that this ideal representation of the UI that is kept in memory and sync with the real DOM. So this process is known as the reconciliation. So this is what allows now React to, by interacting with their API, to allow to describe the UI state that we want to, and let now React to match that state with the DOM. So this now allows this ability to actually this focus on is on the UI elements rather than having us to manipulate is the DOM or update the data attributes or it is content. So we're delegating that to React. Now, this is something important to actually remember or to recap because there is something called the React Fiber, which is this reconciliation engine that started from the React 16, and now they throw or launch that to mhm. And now they launch that and yeah, and then now they launch that yeah, they launched that reconciliation engine as a way to now yeah, as a way, yeah, they launched this reconciliation engine as a way to now set the foundation of what's coming next, which is in the React 18, for example, and that is concurrent rendering, which now we have the ability to using the use transition uh, called concurrently is a rendering. Uh, with the case of or priority type, we also have the ability to give prioritization or rendering prioritization. For example, with use deferred, you say, hey, I just want you to focus on rendering these components and then someone else. As well as the ability to start, pause, and resume is a rendering phase. So on the commit phase, where now React actually contains all the necessary data to apply those changes to the DOM by saying, hey, if this was caused by a root element, because I already create all of these elements in the render phase, now in the commit phase, I'm going to apply those elements to the DOM. This is one. And the other is, if this was caused by a re-rendering, then I'm going to apply is only the bare minimum, only the bare, again, I'm going to apply is the only bare minimum change as long as there are different between rendering. So once the browser detects those DOM updates or those changes on the DOM, it repaint your app. This is a mechanical process that happens over and over and over and over and over at a now sim. Okay, and understand this will now lay down the foundation of, for example, how you can is to think is on state as a snapshot during every rendering, which means that they are asynchronous, which means the current value or the state current value will be reflected in the next render, and you can think of when you are updating your state that React fixed your state inside of your event handler. As a way to now sense a series of sequence events, all right? Now how you can is, okay. Yeah, as a way to now sense a series of sequence events, okay? Pretty much like that. Yeah, as a way to now see of how these sequence events, or as a way to now sense a series of state updates, okay? You can now is perform things on your event handlers. For example, perform now async tasks or work with the previous state when you're going to apply that. We also look at how you can now think in React as a way to now how you can update your objects or an array in the state. The TLDR of that is always returning a new state out of that, which is great. Okay. And also now how you can is yeah, how do you put it? And also now how you can is when it comes to work with uh, your UIs, especially since the reason of using React is that allows to describe this UI. We need to think of then on how we're going to manage our state as we scale an application, which means is that we need to think is we need to learn how to think in terms of React about how to think UI change as a state change. And that's one of the reasons we have, for example, think of your UI, or they provide some principle here to start thinking your React components. Like you identify all the different visual state, then determine what trigger those state updates, represent those state with represent those states with represent those states with use states in memory, avoid any non-essential states, and last but not least, then connect the event handler to update the states. So this is a particular process of you're going to do anytime you want to define is a US state, right? So way to give you now this particular mental model. Uh, and when it comes now to organize our states, how helpful it is by following this principle is that avoid any non-essential, avoid group related state each other's, avoid contradictory state, duplicate states, um, uh, duplicate states. What's next? Avoid duplicate states, duplicate state, redundant states, and deeply nested object in your state. So when it comes now to so far we look at how we can think of UI state as a state change, and also how to organize our states. So when it comes to actually now share that state across different components, we need to also is now look at how we're gonna do this. And when you are doing that, this is now at lifting a state up. This particular process, which is something that you're gonna do a lot of the time, is also the way of how you're going to now write your applications here in how you're gonna write your applications here. Okay. So how you're gonna write your applications here, and by thinking in the React way, which means first you need to have, if you're going to write this UI, first you need to have this, or the data model, especially in a JSON, or is the mock. All right. So whether you have them, you need to create now the components hierarchy. So break down break down your UI into components hierarchy, and here when you are going to identify is which components actually need to be created. Usually when you go with a data model, actually it naturally falls into that, because usually the data models share the same shape of your UI, okay? Or you can also go with the way of how now the designer organized the UI. But in which both of these cases, you actually, this is where you can take a look at that. So after you create now the components hierarchy, it is time for us to build a static version using is the data model, okay? This is when you're going to pass this down data through all of these components, all right? And then after you create that static version, you're going to identify the minimal but complete representation of your UI state, okay? And that is, you can answer a couple questions. hey, is this data doesn't change often? That's not an state. Are you getting this data from its props? That's not an state. Can you compute this data from its props or from states? That's definitely not an state. What left probably is an state, which is something that is described here under docs. So once you do that, it is now indicate is where this component, where this state component will live. This is one of the reasons why we're looking at the share the component state. Why is that? Because the component that you choose that the component that you choose that state will live or owns that, it will become the source of truth for all of the other components that can or need to them. So that's what we have, for example, now components called now uncontrolled components, control components. So control components is when the information that you're getting from this component is mainly driven by this state. However, if your main data or your main information is driven from this component is the main if the main driven info if the main driven data from this component is if the main data from this component is driven by its props, then you're going to this is called now as control component. Okay, the subtle difference here is in terms of describing is what this component does and what is its capability. Again, this your states and your props can change, so this can actually change that, but this is a terminology that they're using because for the use cases. So this uncontrolled components usually have configurations, and uncontrolled component is usually configuration. They are not flexible, and control components are usually is more flexible. This is some components that are going to get some data from that. So once we look at that, and when we need to react, or the more inputs a particular state needs to react, it will make much more sense to actually organize that to make it our state of the logic maintainable, aka using the reducer. So reducer is just a function that allows you to do that. I'm not going into the weeds of this, so no problem. But yeah, I'm not gonna get into the weeds out of this, okay? But another thing that we also look is that how now React fix our state, which means that when you want to preserve the state or not. So React keep track of which state belongs to which components. Exactly. So React keep track of which state using a hash map, I'm assuming. So React keep track of which state belongs to which components based on their place in their UI tree. So you can control when to preserve a state and when to reset it between re-render. Mm-hmm. So state is tied to the position in the tree. So if you want to reset the state from the same, so by default, React what it does is to preserve the state of the same component at the same position, or reset the state of the different component at the same position of the DOM. Because at the end of the day, well, React keep track of the state of that component. Mm-hmm. And is tied to the position in the render tree. So if you want to now, so React say, hey, if you want to now reset the same components at the same position in the render tree, you either rendering in a different position, or using a key for that. So far so good, because now this actually give us is an understanding of also how can we now pass down data to distinct components using context, because it solves this particular problem known as props drilling. And you might feel tempted to overuse these components over and over and over, and this is not what it's meant to be. They provide you a use case of how you, the most common use case where you're going to use this context, which is for analytics, for small app applications, or for small app level data. For example, app analytics, or the for example, the analytics, or the what else? For example, the analytics, or the yep. So for example, the analytics, which is one. So for example, with the analytics, which is one. Yep. With analytics, which is for example, with analytics, which is one. Or with theming your application. For example, React Router actually using context behind the scenes as a way to keep track is the current position of where the user are currently, where the user currently at, as a way to keep track, as a way to now know at which URL the current user is at. And also you have now is the context and reducers, but there is a caveat of using now context, because anytime a context is being rendering, or React will call those components. Yep. So yep. All right. So React will now re-render that components. React will re-render now all of the children components that make use of that particular context, starting from the providers, that value change. So you can solve this by using optimization techniques like MIMO or callback, which what it does is to catch this computation using MIMO, or catches this function reference using callback, right? So then, now that we look at how can we describe our UI components, managing state as a way to now show data in real time and keep that in sync, as well as when it comes to design of UI, how now we need to think of them as UI state or UI change, as UI change as state change. Okay, how can we organize that? How can we now is preserve the state, resetting the state, now share the state across all different components? How can we make our state update logic consistent, maintainable, and how you can now pass down data to distinct components without passing down through a long chains of props? And when it comes to actually connect with external system, which is part of the escape hatches, how useful and what most of your application logic and data flow shouldn't rely on this feature. Because at the end of the day, this is just for synchronizing with external system, or when you need to have control of them. So that's why we look at the use ref For that, um, mhm. So in this section, we look at, for example, when we need to actually connect to external systems. First, the use ref, and how the use ref now this is this secret pocket that allows to remember things between re-renders without trigger a re-rendering. After all, this is just an object that has the dot current property. What is in there, what you can hold is, for example, timeout ID or DOM elements, all right, which is most of the common use case. And when the use effect fits in the entire rendering mechanism is by React initialize the use ref before the commit and then assign the value after the commit phase. And how can we now work, for example, with useref as a way to now get DOM elements? Okay, most of the time for focusing on an input or an element, or you want to scroll or know the dimension of these elements, for example. And when it comes now to connect to external systems, which means, and also you can connect to a video player like that, but there are more better alternatives to do that. When it comes to actually connect to an external system, whether it's connecting to a server and then start listening to message, use effect is now this hook that allows us is to render side effect code that happened after the commit phase. So yeah, they happen after the commit phase. So what does it mean? That is that the community, the React community, decide to, any time that this component gets rendered, if you're using an effect, this will be run as a caused by rendering itself, and this execution will happen is after the commit phase. So when it comes to look at the component anatomy, you have two type of logic. You have is the component logic, which must be pure, and this is when you define inside anything that you define inside of your component is reactive. For example, whether it's your props, states, or values, they are reactive. Okay, and then you have now the event handling logic, which is the way of how you can now is perform side effects. For example, network calls. Okay, so because if you're in the development mode, most of the time, again, remember, most of the time you wouldn't need to use an effect. If you find yourself to actually update and stay from another state or a piece of a state, you don't need an effect. This is solely for connecting to an external system. So, because by default, the use effect is this hook provided by React, where you now put is a logic there, and initially it's going to run that always after every commit phase by default. So if you specify now as an array of dependency as a second parameter, now you are going to run this code, the setup code, after every commit. So when the dependency changes. So to describe is the life cycle, we're gonna do that before, but typically when you are now writing your use effect, in the case of React 18, you have now this strict mode that it tells you, hey, it is time for us to, uh, yeah, hey, it is now, yeah, when you're defining is this, okay, uh, yeah, what you're defining is, mm-hmm, mm-hmm. So I hit the brake here a little bit, just because. So I also yeah. So what we're describing is now the when it comes to use now the React. So on React 18, what you're using is the strict mode as a way to now prevent some common bugs. React will now rerun your applications. So React will re-render and rerun your effects. So React will rerun your components and your effects twice. So instead of actually see how you can get rid of all of this duplication, think of them and how you can now make it work with the cleanup function, especially if you're using effect. And typically, when you're running a use effect, it will fall into these categories. So whether it's you are connecting to a non-React widget, so for example, a map, for example, Maxbox, MapLG, blah blah blah. Whether you are is um, communicating to, yeah, whether you are Mhm. Whether you are communicating to, mhm, all right. So whether you are communicating is, or whether you are now synchronizing with animations, the animation APIs, or you're subscribing to events, and there is a long list of events that you can subscribe from the browser, which is great. And this is something that you most of the time you're gonna do that as well, subscribing to event. That's why we have now this useful hook called use external store as a way to now make that synchronizations to happen as we need it, and how you can incorporate that with your state as a way to make your state sync with now this data that you're getting from. Go beyond the scope of this of today's video. Uh, Also, the data fetching and how you can do that manually, and by using is now the ignore flag, setting it false, perform your async operations, And when you get that data, you can now is yeah, and when you get that data, you can now is actually update your state if there is if the value is false, and because there is no undue network, because you can undo a network request. So the workaround that React provide is to, on the cleanup function, set the value of ignore to true, which means is that or you either abort the operation or you ignore that. So this specific approach as a way to now fetch data from a remote server and now show that is something that you might want to do, is something that when it yeah, it's something that when you want, is something that by running this effect in the data fetching, you now have to deal with other scenarios, which is because your effects are not running on your server, you need to actually is to, well, initially the server pre-render, or initially your server rendered your HTML, sent the client showed the initial page load, and now fetch the JavaScript necessary for adding interactivity, only to figuring out after that that it needs to that it needs to do a network request. So you have now you're duplicating requests. So the other is like catching, because anytime you mount, unmount, and remount the components, there is no way of storing that information. And also, you it wants to prevent some race conditions. Anytime you are sending is or typing too fast, you want to now find a way to prevent this race conditions. As well as if you have now several components that are actually each one of them are sending or fetching data, you now have this network waterfall, which of course slow down your app. And for each one of these cases, the idea here is to say, all right, now, okay, what we want to do is the way to solve that. Frameworks like Next, Astro, or Remis actually solve these particular data fetching problems. Or some client data fetching catching libraries like React Query or React Router, as well as the use SWC from Versa. Or you can implement your own, right? By saying, now you need to not only, so you're gonna use the use effect, but also you have to avoid the duplicated requests. Avoid the duplicated requests, avoid network waterfalls, and provide the ability to catch this data, which is not a trivial thing. Similar for the routing. And another thing that you're gonna write is for analytics. Okay, when you want to, for example, anytime that this component is loaded, you want to somehow is that send some analytics to your service, right? And how instead of doing, how you can have a flag to actually only run this environment in staging. Okay, so hey, I just want to run this application in a staging environment to actually log that application, and in production you have another staging environment, or the production environment. So you don't want to mess up data with your you don't want to mess data here. So you have now a staging and an environment. So instead of actually running that on development, which you can populate that at now sale, you preferably have an staging environment. So in any case, So once we look at that, and also if you want to initialize something, put it at when the application is run. Okay. Also, we look at when we don't need to use a effect. So if your state updates is from a props or from an state, instead of using an effect for that, calculate them. Also, we look that if you want to um, if you want to catch computations, use Memo for that. All right. And I know I'm memorizing that, but the idea here is to imagine those scenarios, which are highly likely possible. The other is that if you want to reset an state uh, when a prop change, so use a key for that, and as an alternative. If you want to adjust some state based on a state or prop change, recompute that. Sharing logic across event handlers as a way to prevent you need to use as an effect. Okay. Uh, do not use as an effect to send HTTP post request, to send data, or to change computation, uh, or to change computation. In fact, inside of the event, and by change computation is by change is a state updates computation. So do handle that is inside of the event handler. Initializing the application, something that I already mentioned. Notify pattern components about state change. You use as an event handler for that. Hey, this is state. Hey, pattern. This is state updates from its children. Hey, you use as a state chain for that. So you're notifying is based on its props or from a context or from a Redux store. So you don't need an effect there. And the other is passing data to the parent. So lift the state up, okay. And something that I think that we're gonna do that is subscribing to an external store. Sometimes your component might need to subscribe to some data outside of the React state. Let me take a look at this thing here briefly, because I think that is okay. So far so good. Okay. Because when you're subscribing to an external store here, sometimes your component may need to subscribe to some data outside of the React state. All right. Exactly. Sometimes your component needs to subscribe to some data outside of the React state. Hey, I need to actually, this is something interesting for the event. For example, here the event page here, the event on the browser, the browser event. All right. The events are fired to notify code of interest in change. So, for example, we have animations. We can subscribe to the animations, web API. That's quite interesting, the web API animation. And I never use that. I use the canvas. Okay. Clipboard, something like we are going to use it. All right. Clipboard, CSS transitions, drag and drop, focus, form, full screen API, gesture, history, inputs, keyboards, manifest, messaging and mouse. Most of the time we also use a lot of the mouse event. Network connection, event file on Windows, event file on network information. The network information API is featured, is available in web workers. So now you can have access to that. From the navigator. The instance consists of a simple network information object, an instance in which is returned by the navigator.connection property of the worker navigator.connection. So now you can have access to this navigator.connection, which now returns a network interface for that, which is this is the shape of this network interface. Download link, effect type, RTT, which is read-only property. The round trip, okay, the round trip time. Change like this. Navigator connection like that. So, but the idea here is to actually look at all of the print, the sockets. Very familiar with this. The touch, force touch ID, virtual reality, RTC, where RTC API, server sends events, speech, events related to the web API with the web speech API, events related to the web worker API, service worker, broadcast channel API. Again, you can now subscribe to an external store. Okay? Usually is an event for that. Here we are subscribing is to window events. Part of the network, like online and offline, for example, right? Navigator.online. All right, hey, listen to this offline and online event, connection events. As you can see, they are. So this window object contains also several of these events attached to this. So you not only have is this event, listen to an event, add event listener for that, say error, language change, resize and storage, but also you can listen to the clipboard events, connection events, device orientation, focus, gamepad, history event has changed, pop state, page height has changed, low and unaverage. This is from the history event. And the pop state file when the active history entry change. Loads and unloads event, before unloads, loads, unloads, manifests event, messaging events, print event, after print, before print, promise rejection event, rejection handle, deprecated event, and this one. Interface C down reference. So, but as you can see here, this is only a few of them. There's a lot of things, there's a lot of events that are not supported or property for that matter. Okay. And here we are looking is not only at the property but also as the instance methods. All right, which now are globally available for us thanks to the web API. You know, thanks to the web API. Okay, thanks to the web API, we can have access to the instance property and the instance methods, as well as the events for that. So this is quite interesting because if you need to synchronize with which one of these systems, right, or is one of these, if you need to subscribe to this, which is data that is outside of your React state. This data could be a third-party library or a built-in browser API. Since this data can change without React knowledge, you need to manually subscribe your components to it. Exactly, since this data change without knowledge, since this data change without notifying its React, without React knowledge, you need to manually subscribe your components to this. And doing these manual subscriptions, and this software is done with an effect. Subscribing to an effect to an external store. Inside of your effect, you define now an state that when these components run initially, I want you to now subscribe to this or synchronize that. Which means that when you run this effect, I want you to define is a function handler, this logic here, that update that state and then append that to the event listener handler function. So here's a component subscribes to external data store, in this case a browser navigator online API. Since this API does not exist on the server, so it can be used for the initial HTML. So the server is rendering that, it doesn't have that, so it needs to, when the server sends that HTML, show the initial page load or the load page. The browser requests that JavaScript code to the client, and now it's going to run the effect, which is exactly now you can is connect to that or run this side effect code. Here's the component subscribed to an external data store, in this case for that. Since this API does not exist on the server, so it can be used for the initial HTML. Initially, the state is set to true, okay, whenever the value that data stored change in the browser. The component, whenever the values of data stored change in the browser, the components update, it is a state. Although it is common to use effect for this, React has a purpose built-in hook for subscribing to an external store that is preferred instead. Delete the effect. Exactly, you need to synchronize with an external store or data that React is not aware of that. Data that React is not aware of that. Okay. Although it is common to use effects for this. So you can replace this. This is just subscribe. This is what you want to do. But creating now this function, instead of using an effect for that, use sync external store. Use external sync. Use sync external store. Subscribe, get a snapshot, and get server snapshot. Is a React hook that let you subscribe to an external store. To do store dot subscribe to do store dot get snapshot. It returns the snapshot of the data that is stored. You need to pass two functions as argument. The subscribe function should subscribe to the store and return a function that unsubscribe. The get snapshot function should read a snapshot from the data from the store. If the store is mutating during a non-blocking transaction update, React will fall back to performing the update as blocking, specifically for every transition update. Subscribing to an external store. Most of your React component will only read data from its prop, states, and context. However, sometimes a component needs to read some data from some store outside of React that change over time. This includes third-party state management library that holds state outside of React. Browser API that expose a mutable value and event to subscribe to the events. Call using external store as a way to now is read some data outside of React at the top level of your components to read a value from an external data store. Okay, I want you to now subscribe to that. And the to-do store gets snapshot. It returns a snapshot of that data of the data in the store. You need to pass two functions as argument. The subscriber function, pretty much like the setup function, but in this case you are subscribing to that, to the store, and return a function that unsubscribe. The get snapshot function should read a snapshot of the data from the store, and React will use these functions to keep your components subscribed to the store and re-rendering on in change. Interesting. So when that external store changes, React now will keep track of that. It's going to compare those state and re-render your component. So you have to do store, where you're going to pass is now the subscribe. Okay. And the subscribe you're going to get is the listeners. Okay. So it's actually now having is this to do store listeners and return the listener and adding that new listener. You have now a collections of listeners. Okay, and then you're going to return now the actual listener. Okay, you're gonna return is a collection of the actual listener that is different from the listener. Or filter. Filter by this. Hey, is the current listener is different from the listener? Get me that. I'm gonna get just only one. Okay, get me that listener. Okay. And then to do store get snapshot. And then to do get snapshot, which is return the to-dos. And you also have is this. This is an example of a third-party store that you might need to integrate with React. If your app is fully built with React, we recommend use React State instead. Again, this is go beyond the scope of this, which is we know that exists. Okay, you might not need an effect when you need to subscribe to external store. Okay, you can use this use external as a depend of this external store. So for example, third-party libraries will build in browser API. Most of the time, at the end of the day, the life cycle of reactive effect, okay, is now so the effect is doing two things. It starts synchronization. So the effect represents is a synchronization process that you can start or stop. This is the two things that that effects can do. It starts synchronization of something and then later on stop synchronizing it. Okay. Good. Effect have a different life cycle from components. Hey amigo, ¿todo bien? From components. Component may mount, update, or unmount. An effect can only do those things. Exactly. And here we're going to look now at the life cycle of the reactive effects. Okay? So, because so far we look at when you need to. So far we have looked at what is the use ref, when you can use ref, how the use ref fits in the rendering mechanism. What is the most common use case with use ref for store the timeout ID or a DOM element reference, or to store is any JavaScript object that is not needed at GSX calculations. How can we use now the um, use ref with the DOM? Okay. Um, mhm, for example. Um, mhm, mhm. So yeah, after we look at the use ref and how you can manipulate with DOM elements, what are the main use case with DOM or with the use ref elements, right? So for example, to focus on the input or to know the size of the dimension of these elements or to scroll them, and how we can use now use effect as a way to now synchronize with external systems. Uh, what is the anatomy of the logic anatomy in our components, the components logic or the rendering logic and the event logic, and how now from that we look at what is the so why do we how use effect fits into this as a way to now run these side effects caused by rendering itself, and how you might not need an effect if you don't need to synchronize with an external system. What will happen when you're starting to define your effect? Okay, like when you because you want to subscribe to external system, you want to mhm, yep, because you want to subscribe now to external systems. What will happen now then next? Um, mhm, mm-hmm. Because you want to subscribe now to the external system, uh, how you can describe a use effect, which is what will happen by default. So you're gonna run this side effect code after every commit phase, and how you can now prevent that behavior by passing is an array of dependency, and when this array of dependency actually change. So when it comes to define is the anatomy of the life cycle, how we're gonna see that later on here, how you can now make work, how you can work with your effects in development mode, because it reruns twice as a way to prevent some kind of gotchas in your states. And what are you most typically write your effects that fit one of these pattern, or you connect to a third party component, to an unreacted to an unreact widget, or perhaps you want to connect to an animation, or to subscribe to an event. You want to fetch data from that, and how now it becomes quite finicky, because since we cannot undo a network operations, we need to find a way to actually is work with the new state anytime we want to perform is this uh, side effect code. and what are the trade-off with using a particular approach that provide React for data fetching, and how you, which is, or the problem is that data redundancy or network duplications, network duplications, catching, race conditions, as well as the uh, network waterfalls, and how now frameworks like Next, Remix, they come out now with a solution for that. Or you can go with this client-side data catching libraries like React Router, um, React Router, React Query, or USWC, or implement your own. But you need to actually deal with these problems, which is not a trivial thing. And also, how you can now is incorporate is analytics when you use effects. When you might not when you might not need an effect is like when your state updates, when you want to detect anytime you need to rendering data that is needed at rendering, you don't need an effect. And if you handle or handling user events, you don't need an effect. So this is also typically now is on when the prop state change, you might feel tempted to use. So you don't need to use an effect when you're a prop, when you want to check if your props, if you want to check if an state or a props, if when you want to check if a state updates based on its props or another state, you don't need an effect. Or subscribing to an event, or catching that computation in GSX calculation, or or catching that computations, or adjusting some states based on adjusting some states when the props or change need change. Adjust some state when the prop change, which means is uh, recompute those values, sharing logic between event handlers, sending an HTTP post request, change state computation, or change of effect, mm-hmm, change of computation, change of state updates computations. Handle that inside of your event handlers. Notifying the pattern about the state updates, so you can use the so you emit that event or you update that event inside of the event handlers on your children's. When you want to pass data to the parents, you now state that you leave that state up, all right, and then you pass down to the proper component that it needs to pass in data to the parent. And the other is subscribing to external storage. Okay, this is very narrow specific to React. When they say, hey, let's say you want to now is to synchronize with an external storage, whether it's a third-party library or a built browser, building browser API, okay? And since this data changed without the React knowledge, we need to find a way to actually notify React about it. You can use as an effect, okay? But instead of doing that, they say, hey, uses the using external store. There's a specific hook from that. And the other is that fetching data. You might not need an effect in this case if you're going to use this, right? When the page changed, that's what you need is the ignore flag here as a way to prevent any race conditions. This is called as a race condition. Two different requests race against each other and came into different order that you expect. To fix race conditions, You need to add a cleanup function to ignore stale response. Race condition, and even in the low, holy shit, a race condition or a race hazard is a condition of an electronic software or other system where the system's substantive behavior is depending on the sequence or timing of other uncontrollable events, leading to unexpected or inconsistent result. It becomes a bug when one or more of the possible behavior is undesired. The term race condition was already in use by 1954. David A. Hoffman, doctoral thesis, the synthesis of sequential switching circuit. Race conditions can occur especially in logic circuit or multi-thread or distributed software program. Race conditions can occur especially in logic circuits or multi-thread or distributed software program. Using mutual exclusion can prevent race condition in a distributed software. Mutual exclusion. Mutual exclusion. Interesting. Very, very interesting. But the race condition can happen in circuits, multi-threading, and in distributed systems. So the way of how now you can solve this race condition, okay, is by by using the cleanup function. This issue applied to any UI library, not just React, and solving them is not trivial, which is why modern frameworks provide more efficient built-in data fetching mechanism that fetching data in effects. If you don't use a framework and don't want to build your own, but you would like to make data fetching from effects more ergonomic, consider extracting your fetching logic into a custom hook like in this example. So hey, I want you to now extract this logic to be more ergonomic, to be easy to use. To be easy to use. Okay, so that'll be all for this video. Yeah, that'll be all for this video. Mm-hmm. Oh my god, that'll be all for this video. Take care. Bye bye.